DesignMyBirdhouse.com, the world's leading supplier of customized birdhouses. On DesignMyBirdhouse.com, customers can choose from different birdhouse models. And for the model they've selected, they can choose both a custom color and a custom style. Each model has its own range of available colors and styles. One way of capturing this information is to put all the possible combinations in a single table, like this. This table is in third normal form. The primary key consists of all three columns: model, color, and style. Everything depends on the key, the whole key, and nothing but the key. And yet, this table is still vulnerable to problems. Let's look at the rows for the birdhouse model Prairie. The available colors for the Prairie birdhouse model are brown and beige. Now suppose DesignMyBirdhouse.com decides to introduce a third available color for the Prairie model, green. This will mean we'll have to add 2 extra Prairie rows to the table. One for Green Bungalow and one for Green Schoolhouse. If by mistake we only add a row for Green Bungalow and fail to add the row for Green Schoolhouse, then we have a data inconsistency. Available colors are supposed to be completely independent of available styles, but our table is saying that a customer can choose green only for the bungalow style, not for the schoolhouse style. That makes no sense. The Prairie birdhouse model is available in green, so all its styles should be available in green. Something about the way the table is designed has allowed us to represent an impossible situation. To see what's gone wrong, let's have a closer look at the dependencies among models, colors, and styles. Can we say that color has a functional dependency on model? Actually, no, because a specific model isn't associated with just one color. And yet, it does feel as though color has some relationship to model. How can we express it? We can say that each model has a specific set of available colors. This kind of a dependency is called a multi-valued dependency, and we express it with a double-headed arrow like this. And it's equally true that each model has a specific set of available styles. What fourth normal form says is that the only kinds of multi-value dependency we're allowed to have in a table are multi-value dependencies on the key. Model is not the key, so the table model colors and styles available is not in fourth normal form. As always, the fix is to split things out into multiple tables. Now, if DesignMyBirdhouse.com expands the range of Prairie model colors to include green, we simply add a row to the Model Colors Available table. And no anomalies are possible. We're now ready for fifth normal form, the last normal form covered in this video. As our fifth normal form example, we imagine that there are 3 different brands of ice cream available: Frosties, Alpine, and Ice Queen. Each of the 3 brands of ice cream offers a different range of flavors. Frosties offers vanilla, chocolate, strawberry, and mint chocolate chip. Alpine offers vanilla and rum raisin. And Ice Queen offers vanilla, strawberry, and mint chocolate chip. Now we ask our friend Jason what types of ice cream he likes. Jason says, "I only like vanilla and chocolate. And I only like the brands Frosty and Alpine." We ask our other friend Susie what types of ice cream she likes. Susie says, "I only like rum raisin, mint chocolate chip, and strawberry. And I only like the brands Alpine and Ice Queen." So after a little bit of brain work, we deduce exactly which ice cream products Jason and Susie are willing to eat. And we express this in a table. But time passes, tastes change, and at some point, Susie announces that she now likes Frosty's brand ice cream too. So we need to update our table. It won't come as any surprise that we might get this update wrong. We might successfully add a row for Person Susie brand Frosty's flavor strawberry, but fail to add a row for Person Susie brand Frosty's flavor mint chocolate chip. And this outcome wouldn't just be wrong, it would be logically inconsistent, because we've already established that Susie likes Frosty's brand and likes mint chocolate chip flavor, and therefore there's no way she can dislike Frosty's mint chocolate chip. In this example, we went wrong right at the beginning. At the beginning, we were given 3 pieces of information. First, we were told which brands offered which flavors. Second, we were told which people liked which brands. Third, we were told which people liked which flavors. From those 3 pieces of information, we should have simply created 3 tables. And that's all we needed to do. All the facts of the situation have been represented. If we ever want to know what specific products everyone likes, we can simply ask the database platform, expressing our question in the form of a piece of SQL that logically deduces the answer by joining the tables together. To sum things up, if we want to ensure that a table that's in 4th normal form is also in 5th normal form, we need to ask ourselves whether the table can be logically thought of as being the result of joining some other tables together. If it can be thought of that way, then it's not in 5th normal form. If it can't be thought of that way, then it is in 5th normal form. We've now covered all the normal forms from 1st normal form to 5th normal form. Let's review, keeping in mind that for a table to comply with a particular normal form, it must comply with all the lower normal forms as well. The rules for 1st normal form are 1. Using row order to convey information is not permitted. 2. Mixing data types within the same column is not permitted. 3. Having a table without a primary key is not permitted. And 4. Repeating groups are not permitted. The rule for 2nd normal form is each non-key attribute in the table must be dependent on the entire primary key. The rule for 3rd normal form is each non-key attribute in a table must depend on the key, the whole key, and nothing but the key. If we prefer to drop the phrase non-key, we end up with an even simpler and even stronger version of 3rd normal form called voice cod normal form. Each attribute in a table must depend on the key, the whole key, and nothing but the key. The rule for 4th normal form is that the only kinds of multi-value dependency we're allowed to have in a table are multi-value dependencies on the key. Finally, the rule for 5th normal form is it must not be possible to describe the table as being the logical result of joining some other tables together. I hope you found this video helpful.